Example 7.1. Find the center of mass of three particles at the vertices of an equilateral triangle. The masses of the particles are 100 gram, 150 gram and 200 gram respectively. Each side of the equilateral triangle is 0.5 meter long. Now here see, we consider one equilateral triangle for which one vertex is at the origin of the Cartesian coordinate system. Here in this XY plane, equilateral triangle is represented. Now suppose at origin, coordinates are 0, 0. Particle number 1 is placed. Its mass, that is 100 gram. Then on x-axis at distance 0.5 meter, because each side that is 0.5 meter. Another particle with mass 150 gram is placed, and at third vertex of this triangle, third particle mass 200 gram is placed. Now we want to find the center of mass of this system of three particles. Okay. Now we have the equation for the position of center of mass. So x coordinate, that is m1x1 plus m2x2 plus m3x3 upon m1 plus m2 plus m3. And for y coordinate, y equal to m1y1 plus m2y2 plus m3y3 upon m1 plus m2 plus m3. Masses are given to you. M1, M2, M3 are given to you. But first of all, we have to take x1, y1, that is the position of or coordinates of the position of particle number 1. Then x2, y2, the coordinates for the position of particle number 2, and x3, y3, coordinates for the position of the particle number 3. 1 is at origin. So x1, y1 both are 0, 0. Particle number 2 is on x-axis at a distance 0.5 meter. So x coordinate, that is x2, 0.5, and y2, that is 0, this one. Now for third one, say this particular side is 0.5 meter and angle is 60. So for this point, the x coordinate, if we draw normal here, then this part will be 0.5 cos 60. And if we draw normal from this third point to y-axis, then this part will give you y coordinate, that is 0.5 sine 60. So x3, that is 0.5 cos 60, y3, that is 0.5 sine 60. Cos 60 is 1 by 2. So 0.5 into 1 by 2, that is 0.25. Then 0.5 into root 3 by 2, that is 0.25 into root 3. Now substitute all the values. M1 100, X1 0 plus M2 150, X2 0.5 plus M3 200, X3, this one 0.25. Divided by 100 plus 150 plus 200, then solve this one, you will get x coordinate for the position of the center of mass. Then y, that is equal to m1 100, y1 0, m2 150, y2 0, m3 200, y3 0.25 root 3 upon 100 plus 150 plus 200. Again solve this one, you will get y coordinate for the position of center of mass. So finally we can give the position of center of mass, that is equal to, now here you have to write x coordinate and here you have to write y coordinate. That is your answer. Clear to all? Now suppose we have a rod with uniform cross section and uniform density with length equal to L and mass M. Okay. Now this rod is coinciding with x-axis and we want to find the center of mass of this particular rod. Here this one is the linear object and it is coinciding with x-axis. Obviously the center of mass, that will be on x-axis. So as discussed in the previous theory, we can write the equation for the position of center of mass, xcm. X, that is the position on x-axis, cm stands for center of mass. That is equal to 1 upon m integration x dm. Now here we have to divide this entire rod into so many infinitesimal small elements, and then we have to integrate it starting from 0 to L, because we have to consider this type of element from x equal to 0 to x equal to L. So here see, limits are taken as 0 to L. Now this one is one element having mass dm, which one is situated at distance x. But first of all, we have to think about this mass. How much mass is this one? Now see, mass per unit length of the rod, that is m by L, because mass of length L is m, therefore mass of length 1 meter is how much? Simple unitary method. So we can write m by L. Now element with length equal to dx is suppose under consideration. Here we have to write either or, here or here, take dx. Okay. Now mass of 1 meter is m by L, therefore mass of dx meter is how much? So we can write dm, that is m by L dx. Now this dm is now replaced. So xcm equal to 1 upon m integration 0 to L. Dm is replaced by m by L into dx, and this x, that is as it is. Mm cancelled. 1 upon L integration of x, that is x square by 2, limits 0 to L. Take this 2 outside the bracket. So 1 upon 2L. First we have to substitute x equal to upper limit L, so L square, then x equal to lower limit 0, so that is 0. So we'll get resultantly xcm equal to L by 2. So we can say the center of mass, that will be at midpoint of the rod. Clear to all of you?